Okay, good evening today. Right.
Yes.
Okay, we have discussed about our microcontroller lesson last day. So when you are talking about the microcontrollers, hope you can remember that we discussed microcontrollers are like small computers. So we call them single board or single chip computers. So either we can call single board or you can call single chip, even single board computers or single chip computers. That means very small computers having same components as computers. That means it can input and process and produce some information. But there is a specialty, unlike the computers that you see day by day, right? Unlike the computers that you see, these microcontrollers are taking inputs from sensors, because like computers, we can give inputs using the keyboard and mouse, right? You can feed inputs. Feeding means like the user should be there and the user can feed it using the input devices. But these sensors are capable of automatically sensing the environment and taking the inputs. For an example, let's think about the temperature sensor. Temperature sensor can feel the temperature in the environment, and if it is going above or going below a certain tolerance level, it can produce a signal or it can trigger an input. So that is the specialty, right? It uses sensors. Sensors are automatically sensing the environment. So no need to wait till user trigger or user inputs. Therefore, these microcontrollers can take fast decisions, real-time decisions mostly. Fast and real-time. Real-time means same time it can take decision, because so think about, okay, you are assigned a duty, and you are given a task to turn off and turn on a light. It is highly dependent on you. If you feel sleepy, sometimes you might not turn off the light in the early morning. So let's say you slept until 10 a.m. in the morning, and then when you wake up only, you remember you can turn off the light. But these microcontrollers, it can sense the sunlight. When the sunlight present and it is above certain tolerance level, it can automatically turn on, it can automatically turn off the bulb. So which is more realistic? The realistic one is microcontroller, because if you're doing this manually, it's not realistic. It is realistic, yes, but the thing is, it highly depends on your inputs. ඔයාගේ input මත රඳා පවතින. ඔයා off කරොත් හරි. ඔයාට අමතක වුණොත් අමතක වුණාම තමයි. But sensors are more accurate and real time. So that is the advantage. Then we learn about these components inside the microcontrollers. It is similar to the computer. Similar to computer, there is a processor which can process these inputs, and there is a memory, and memory can be volatile, non-volatile. So what's the difference? Volatile and non-volatile? What is the fundamental difference?
In volatile memory, the memory will be erased when there's no power, but volatile memory is permanent even there's no power.
Repeat it again.
In non-volatile memory, when there is no power, the memory stored will be erased. But in volatile memory, even when there is no power, the data will be the information will be permanent unless the user deletes it.
It is other way, right? So your explanation is correct, but non-volatile memory is not depending on the voltage. Non-volatile memory can keep the content even there is no power. Right? You have explained the other way. That's why I asked you to repeat. Volatile memory is volatile. Volatile means depend on voltage. When power is not there, volatile memory will be erased. So random access memory is an example. But non-volatile memory can keep data even there is no power. Example for non-volatile memory? Can you tell few examples for non-volatile memory? Yes?
Hard disk.
Hard disk, okay. Anything else?
Pen drive.
Hard disk, pen drive, yes.
RAM. CDs, DVDs.
DVD, memory cards. RAM is not non-volatile. RAM is volatile. Don't confuse. Again, you are confusing. Random access memory is a volatile memory. It's a temporary memory. But non-volatile is not temporary. It is a long-lasting memory. Non-volatile කියන්නේ ටිකක් වැඩි වෙලාවක් හරි වැඩි වෙලාවක් දාගන්න පුළුවන් නම් තමයි non-volatile. Volatile කියන්නේ current එක තියෙනකොට තියෙනවා නැත්නම් නැකෙනවා. හරිද? Okay?
Okay.
Then there is something called system clock. System clock is the purpose of system clock is actually synchronizing. Purpose of system clock is synchronizing. Synchronizing means like we all synchronize now. So whether you are in Galle or Kandy or Colombo or Tampa or Jaffna or Matale or Matara or anywhere, so you name it, right? Kurunagala, wherever you are, you all and me, myself, we are also always logging at same time. So that is 8:20, that is our last starting time. And that is because we all have synchronized clock, right? Synchronized clock. අපේ හැමෝගෙම ඔරලෝසු එකම විදිහට නෙදුවන්නේ. ඒකනේ ඔයාලා මේ වෙලාවට පන්තියේ ඉන්නේ. We have synchronized clock. So system clock is something which is inside the computer, and the purpose of system clock is to synchronize the activities inside that. And peripheral devices, we already discussed that in computing also. Peripheral devices are the input and output devices which are connected to these microcontrollers, and which actually give you, which actually this sensors can be input and there are outputs also. So what type of outputs provided by these microcontrollers? Can you tell a few type of outputs provided by microcontrollers? Yes, what kind of output?
Sound.
Sorry?
Sound.
Sound, yeah, it can be a sound. Anything else?
Pictures.
Pictures, okay. Pictures, screen outputs can be there. Sound outputs can be there. Mainly, what are the output devices it uses? Yes, what are the output devices? Mainly it uses bulbs, motors, speakers, etc. Right? It mainly use bulbs, motors, speakers. ඒ වගේ ඒවා තමයි ගොඩක්ම use කරන්නේ. Okay, I hope these points are clear. Right, then let's move to the, so these are some examples given in the book, right? Some examples given in the book, and right, washing machine, solar lamp, right? Solar lamp, washing machine, microwave oven. So where else the microcontrollers are used in? So what are the other places?
Street lamps.
Cameras.
Lamps, cameras, okay. There are a lot of places. Cameras,
Inside.
refrigerators, TVs, vehicles, especially in the vehicles.
So in some lamps.
Sorry, Bhuti?
Lamps.
Lamps, yeah, it can be anywhere, right? Can be
Robots.
yes, it can be anywhere, like rooms, maybe
Yeah.
classroom, kitchen
Robot.
appliances, home appliances, roads, vehicles, in sports, in a lot of places this is used.
Excuse me, sir. Robots.
Robots, yes, exactly. And we discussed the single board computers and single board computers, single chip computers. Example, Raspberry Pi is a single board computer which has a board, and then that is Raspberry Pi, and then there's another one, single chip computer, that is Arduino. And also you have like this BBC build microbit, which is also a single board computer. Microbit, Raspberry single board, and Arduino is a single chip. Arduino chip itself is a microcontroller, but the other two actually there are developed. These are developed boards, right? So then we learn about the microbit module. These are actually we have done these things last week. Right? So microbit, this board has LED grid, 25 LEDs output, and then so A and B switches are programmable. You can program this and to get some inputs and produce outputs. You can just provide inputs to these switches. And 0, 1, 2 are digital analog pins, which you can provide digital analog inputs, etc. 3 volt is to give the power, and also 3 volt providing power, and then ground is basically that is the earth wire. And the other side of the microbit circuit, you can see, so there is a Bluetooth antenna and the processor, and there is a compass which give the directions and directions, etc. Then accelerometer, speed measurement, movement measurement, and there is a power USB socket and power, and there is a there is a reset switcher, and there are some pins to connect. So these are the things. Okay. So then we'll learn how to write programs to this microbit module and different. We learn about the different inputs, different components there. Okay, so let's move to the microbit environment. To code in microbit, you can go to makecode.microbit.org. That is the link, or you can just go this one. So let me show that. Make code in microbit. So this is the link. You can start new project after visiting this website, and this is the link. I have sent it to you. Please click on the link and visit the website. Then you can click on the new project and start building a new one. And you can give a name. So let's give P3. You can give any name to this and create it. Then the interface will be open and it will look like this. Okay. Right. Visited the site. Okay, then you can see the front interface of this, and also you can see the controllers there. Under the basic components, so there are a few components that you need to know. Show number will display a number, any digit that you are telling. So if you put here show number 0, when you play it, you can see number 0 is displayed there. If you save show number 8, then play it and it will be number 8. And if it is show number 9, still it can display because it is a single digit. But show number 10 will play a small animation, as it cannot display 10 using this 25 grid LED. So it shows an animation 1 0. You can say plain animation there. Show number 10. There is a plain animation. Okay. So that's it. Right, try this, Pute. Okay, the next is show LEDs. There you can show any pattern. So you can draw it, right? You can basically by coloring So if you want to erase something, you have to drag and drop it here. Erasing can be done by dragging and dropping. Right. If you want to show LEDs, you can move there. And let's draw a pattern like this, maybe. Okay, then you can play it and it will show the LED pattern that you are showing. Okay, can you do small thing? I need this is like, okay, this is, assume this as a fan. I need this fan to rotate. Can you create small animation showing the rotation of the fan? Assume this as a fan, make a fan එකක් විදිහට හිතන්න. Assume this as a fan and think that I want to rotate this. මේ fan එක මට පොඩ්ඩක් මේක කරකිනවා පෙන්නන්න. Can you show animation showing this fan is rotating? Can you do that? Small exercise. I'll give you 2 minutes. Just give a try. You can share the screen now. Share the screen quickly. Okay, Shamin, right? Okay. So is it working? Yeah. So I couldn't see anything. Others, did you saw? Did you see? Is it rotating actually? It's somewhat okay. Can't we create something better than that?
Okay, so I'll try.
Just give a try. No, I'm not sure. So maybe you can, maybe you can't. So just give a try. So let's take a duplicate. So I'm telling what Shamin has done. What he has done is he has just rotated this part like this, and this one like this, and this one like this, and this one like this. So that is okay. Then he played this, and when you're playing, you should see like rotating. But it is like not actually visible like rotating, right? It's like shifting between two. But anyway, so this is a solution. This is a solution. I agree with the solution. Cannot say no. I agree with the solution. But can we create something better? Let's try something like this maybe. But this is not very good one, right? This is not very good one, obviously. Just trying. Okay. So then I'm doing something like this. This one. Okay. This part I can just move. Just trying some patterns. You can also try. You can also try, and you can try to do this. Then what? Then what? So if you put it like that, it will not. Just think what you can do with this. Just try it. Just try changing the patterns. Just try changing the ways that you look like. So this is one thing that I can do, but it's not giving the rotation. Still the same. Let's change this position there. No, still not. I don't think that. So let's see. It's something okay. But you can add more step. It shows some rotation, but still not perfect. Just add another step. So likewise, think, and try to do something innovative, right? This totally depends on your actions. Let's play it again. I'm coming back to the same, right? So like anyway, so try to bring something, maybe like still I'm also trying. You can just give a try, maybe looks something better, which is like twisting. This one is there, then come to this one, this stage, then what? So what about this one then? So think about all the possibilities. No, it's not very good word. So what about this? There is also not a very good solution. So, but just give a try, just give a try. You can just come up with a very good solution. This is what I thought of doing, but you can just play around and come up with a better solution. This is what I have come up with. Still, it's like a dancing, right? It's like a dancing. But so try to see, like there are only 25. There's only 25. So you can just innovatively play around and get something. Maybe adding few more steps will give more realistic effect. So let's add 4 steps and try. So then you can give something realistic, a better one. Okay, that is totally up to you. Okay. Right, then one more thing, right? Since you have done this, some of you have tried different versions. Right now, you can think of doing right. I'll give another exercise. Now, so these are the basics, show LED, show icon. Show icon, there are interesting set of icons. You can see this, these are the icons that you can see. Right? These are the icons that you can see. So, but other than these icons, you can create some more icons. So these are the just icons that you can see, but other than this, you can create more icons. So icons are actually predefined patterns. Then you have this text, so different text. Hello. Clear screen will clear the entire screen. Right? Clear screen will clear the entire screen and it will make this grid empty. Forever, you know that forever will repeat continuously, and on start will repeat only one, not repeat, will do it only one time. Pause in milliseconds. 100 milliseconds means how many seconds? 100 milliseconds means how many seconds?
10 1.
Sorry? 10 seconds?
1/10 of a second.
1/10. So it is 0.1 seconds. 10 milliseconds means how many seconds? 10 milliseconds. 10 milliseconds. Yes. Ten milliseconds means 0.01 second. 1000 milliseconds. No, it's wrong, Tian. It's 0.001. 10 milliseconds can 0.01 second. 1000 milliseconds. 1000 milliseconds. Come on, guys.
1
It is
second.
dark.
1 second.
1 second, right? Why don't you reply? Are you doing something else? So this we have discussed many times. It's 1 second. Okay. Then show arrow. Actually, these are arrows to show north, east, likewise different arrows like arrow formats. So this is also interesting. So let's try this today. So let's try with the arrows now. I'm going to show these arrows, right? Let's see what will happen. Show arrow. First I'm showing north. Then I'm repeating, duplicate, and I'm showing the arrow north, east. Showing the arrow, take a duplicate, showing the arrow, this time east. Showing the arrow, this time southeast. Showing the arrow, this time south. Okay, see what will happen with these arrows now. Okay, you can see arrows are rotating, right? Arrows are rotating with this. So this is one side. You can do the other side also. Okay, so these are the arrows, arrow format. Actually, predefined patterns again. Predefined arrow patterns. Okay, then inputs. So this is how you can provide inputs. So one is the simplest one using buttons. You can press the button and using these buttons you can give the.
Excuse me, sir.
Yes.
Sir, what is the meaning of on shake?
On shake means when you shake this, when you shake this, so that is actually using the accelerometer and also this compass. It's detecting the motions. It's detecting the motions. When you move or when you shake this, right here, not just shake. When you shake, when you up, when you lock down, when you strain up, strain down, tilt left. So this is like a gyroscope, right? දැන් ඔයගොල්ලන්ගේ ෆෝන් වල ගයිරොස්කෝප් එකක් තියෙනකොට පුතේ අර හරවනකොට ස්ක්‍රීන් එක ඔටෝ හැරවෙනව නේද? Some phones this is happening. Have you seen mobile phone when you rotate the screen it will automatically rotate the not flip, it will rotate the video or image. Haven't you seen that? අර ෆෝන් එක හරවනකොට වීඩියෝ එක හැරවෙන්නේ ස්ක්‍රීන් එක හරවනකොට දැකලා තියෙනවද? සමහර ෆෝන් වල තියෙනවා. Haven't you seen? දැකලා නැද්ද?
දැකලා තියෙනවා.
Right, okay. If you have like some more now new phones, new mobile phones that has a gyroscope කියලා එකක් තියෙනවා. ඒතර phone එක rotate කරනකොට screen එකත් auto rotate වෙනවා. Right, it's like this has that this has similar functionality. When you rotate, when you up, when you down, when you strain up. So when you strain down, when you tilt left tilt, right tilt, free tail. So when it is falling down, right? And like here, when it knocks somewhere, right? Likewise, this can be sensed. Wonderful, no? This can be sensed. මේවා sense කරලා එක ඒවට commands ලියන්න පුළුවන්. That is this on shape. Then on this pin 0, pin 1, pin 2. So these things are there for pin clicks. Then when this button A, and then when acceleration happens, so when it is fast acceleration, X direction acceleration, Y direction acceleration, or Z direction acceleration. ඒවත් මනින්න පුළුවන් වෙන වෙන. So this physically you can measure, right? If you get the board, I told you how to get this board, right? It's around 6,000 rupees. You can like buy it from Daras. It's around 6,000 rupees now. So some are 7,000 even. So be hurry if you want to buy because the prices are increasing. Then this pin, then the light level. So light level can be sensed. So more light, less light, dark environment for the compass heading. So the direction can be sensed. The temperature can be sensed. So all the sensors are integrated. This is a package. Right? If you get this, it's a package. It has all the sensors. Almost all, right? Not everything, but you have many sensors integrated to that. So that is, then it's better, right? Because you can use that and do something. Then here actually by using shake, so different gestures can be made, right? Again, the same things will be there. These are the inputs. Right, now we know all about the basics, basically outputs and the inputs. And under more, right, you have some other things like calibration, running time. So I'll tell these things when we are doing sensor-based programs. Then for music, you have, so these things are there, right? You can like similar to the stretch that you had. So here you can play melodies. The melody can be here. Okay, so can you remember? So just to remember what we have done in stretch, can you go to music and create the first part of national anthem, please? So I thought you can. I hope you can remember what we have discussed in stretch. Means stretch අපි කතා කරා මේක. First part of the national anthem. So can you try to play that using this melody part? Just drag this. You can use this in one time also, okay, right? One time you can use on start. That is okay. Go to the music, play melody, then composite. So there is a gallery, right? There's a gallery you can apply. This is triggers. Right, by looking at this, you can identify the pattern here. This is what Sarigama Padanesa is. Thinking that as a pattern, taking that as a pattern, can you create for this national anthem, the first part? You know how to do that. Tempo, you can change this using this, but only thing is this is bit different from what you saw in note playing in stretch. This has a grid, edit actually. Just give a try. So if you are done, please tell me, then I'll give you a chance. And use just common sense and your ear. So that is enough. So you don't need advanced music knowledge to do that. Just go to the basic, use on start and then go to the music. Yeah, you can just, here plain notes is also available, right? You can play middle C, one beat, that is also available. So you can use that as well, but I think better you use like grid, the melody one. Right? Better use the melody one. It is easy. Okay, if you're using like this, like you can see this, the problem is like the tempo that you are using is affecting all the, so if you increase the tempo, whatever, so it's affecting all the notes, right? But you can use instead of, so you can use few using these, but like if you're using the second one, this, the play note one, you can do it more realistically. That is also okay, but if more notes are, if notes are similar tones, then you can use it. Notes are tone එක එකන. ඒ කියන්නේ එකම beat එකම මේ tone ඔය විදිහට යනවා නම්, so that is okay, but otherwise you can just use this. Right, this has the keyboard like earlier, so then you can see half beat or quarter beat this. Let's play. Here you can see how the sound connector is connected to seed of pins like that. Okay, you can then, so let's see, let's use the repeat one forever. Then you have to play this one. Let's duplicate it few times. So let's have 6. You can add more, right? I'm just having 6. Then again, same beat. Same. This, and let's put half, 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 quarter, and then full. Let's play. Okay, this is what you are getting, right? Let's stop. And let's change the beat also. Let's go to beat and let's change the tempo. Let's reduce it. Okay. Likewise, you can give the beats and then try. The beats and then try karana. So this is one example. This is similar to the previous example, previous one that we have done. Or if you are trying with the same tones, you can try the melody. Tone එක සමාන නම්. Okay, so how you can connect audio? You saw, right? Audio එකක් connect කරන්නේ කොහොමද? You can use the GND pin and 0th pin, then connect audio like this. Okay. GND and 0th pin, then you can connect this to the speaker. So that is the advantage again. So it's very, very easy. It's very, very easy to customize. Right? That facilities are there. That is in the music section. So you can try the other things, right? Then you have play sound. This play sound one will allow you to add a sound and play it. Okay, let's see the sound. What is the sound there? You can go to the gallery and see here. These are some. This is water drop. Snare. Cowbell. Triangle. You can edit this today. You just select water drop. Let's say you can see the waveform also. Let's play. This is water drop, right? You can see the duration and all. You can increase these things. But that is too delayed, right? You can just here. It's also too much. 200 would be ideal, right? Somewhere here. But you have to start frequency and frequency also you can change. Let's increase the frequency. Then the water drop is falling like this. Likewise, the frequency can also be edited, right? You can add the effect, you can change the frequency, wave format you can change, and you can add different wave formats. Editing these things are possible. You can record your own formats. Likewise, there are a lot of features there. And you can see what is there in the Python code when you convert. So here, these are the things. Switching back to the, okay. So just practice the music part. It has nice things, a lot of things to learn. Then you have the LED, right? LED means like LED grid. So this plot X and Y, you can just plot X, Y. So LED grid can be taken as the Cartesian plane. Cartesian X, so X direction, Y direction. Then you can plot. Let's plot one and see, just to get an idea. Okay, I'm not going to discuss after this, but just to show you the basics, because this is different from what you have learned previously. That is why I'm showing this repeatedly. And let me do this one more time. Okay, let's do forever, but only when, let's go to if, oh no, let's go to this button press, right? Only the button press. Just need to assign that to the input when the button is pressed. I need to plot X0, Y0. So let's see what will happen. Let me play. You can see X0, Y0 is this. So I can change these things. X0, Y1. So what is that? It's changing the Y direction. When I play the button here, X0, Y1. Actually, I can give a delay between these to see. Let's give in basic, and let's put a delay, post 100, and then again post 100. Right? So let's see. You can see this one, and after that, this one will be lighten up. And I need to clear the screen. So I need to clear the screen and do this. Sorry, I need to clear the screen first and then do this. Then let's see what will happen. First on this one, this one. And if I repeat this, if I'm doing this forever, this actually Nadun has done that last day, but just want to show you. You can see these LEDs are blinking. So let's increase the time, right? Let's put 500 milliseconds, and here also 500 milliseconds. Otherwise, this is too fast. Then you can see the blinking effect of this. Actually, I have to clear the screen again before begin. I have to clear the screen again one more time here. Now you can see that LEDs are, it's blinking like shifting and blinking. It's interchanging. Okay, try to use these and create a Knight Rider circuit using this. That is the homework. So take this into your head. So please write down this or capture this. take a photo or capture this, then try to create a Night Rider circuit using this. That is today's homework that you need to do. Okay. Then I'll stop in from here. Next day I'll be discussing about sensors and more things. For the moment, I'll be stopping here. Then good night. See you all next week.
Good night, sir.
Good night, sir. Thank you, sir.